So, part 2, 7.10, talking about angles of a triangle, talking specifically about proving qualities and theorems and ideas about these angles of a triangle. Real quickly, if I give you this drawing and I said, write an equation that describes the relationship here, you'd probably say this one plus that one equals 180. And if this made sense to you when you first read it, quickly, you're doing 3 things in your head. You're doing this in your head quickly. You're getting rid of the 90 on both sides to say that whatever x and y are have to add up and equal 90. In your head, you're probably just doing that really quickly in your head. Now, if I was in class, I'd say, well, what do you call it if 2 numbers add up and equal 90? And then, Dylan would raise his hand. Yeah, Dylan probably wouldn't raise his hand. Audrey would probably yell out, hey, 2 angles out to 190 are called complements. Well, yeah, you can say that they're complements because you understand what complements means. So hopefully you have a quick little 3-step proof here, where in words I'm saying they're complementary, and I'm just trying to show you the link here between proof and theorems. That right there is because the angles of a triangle add up to 180, called the triangle sum theorem. That right there, moving the 90 over, it's called subtraction. We know how to do that. And the last thing is, if you know they add up to 90, you can say they're complementary because you understand that definition. Again, quick 3-step proof. Last one on the front of that page, and then we'll flip over to the back one and do one more. This is one I kind of like, called the third angles corollary. You can probably fill in the blank without having any information here. Maybe just pause and try to fill in that blank. Okay. I want to add some stuff to the drawing out here that represents what this says here. If 2 angles of a triangle are congruent to 2 angles of another triangle, so I'm going to call, pick 2 of these angles, call that one X, call that one Y, and I want to show they're congruent on the other triangle, so I'm going to call one of them X and the other one Y, showing congruent. There's sort of an obvious conclusion about these other 2, but I'm going to call them something different because I want to prove something different here. I'm going to call this one Z, and I'm going to call that one W. What's the obvious conclusion about those 2? Anybody? Oh, Brady again. They're congruent. Yes, of course they are. So that's sort of the obvious conclusion. The third angles, the other angles have to be congruent. 2 are congruent, the other ones have to be congruent. Again, a quick 3-step proof why. It's a good time to pause. See if you can get to the conclusion that Z and W have to be equal. Super easy. So hopefully you're noticing a theme on here. All of these proofs involve the triangle sum theorem. You know that X, Y, and Z add up to 180. You probably know that X, Y, and W also add up to 180. That's my first logical step in my proof. That is the triangle sum theorem. You'll notice my colors are showing this. This blue stuff equals 180. That blue stuff equals 180. Kind of obvious that this blue stuff and that blue stuff have to be equal to each other. In my mind, I could do this very quickly. So, it's obvious. Well, here's the obvious things your mind is doing because you have an honors brain and you're thinking through this so fast. The blue stuff's got to be equal on there. And the blue stuff, because they were both equal to black stuff, there's a simple solution for that, a simple reasoning for that. That's called transitive thinking. Comparing 2 things to the same thing, therefore those 2 things have to be equal to each other. Last step is to get a conclusion on here. You'll notice there's an X there and an X there. Nobody would leave that there. You'd subtract that out, subtract that out. You'd subtract that out, subtract that out, and be left with concluding that Z and W are in fact equal to each other. So we just did some triangle sum theorem again. We're using that theorem to prove these corollaries. You could definitely call this substitution, but it's sort of a classic example of stuff equals 180, other stuff equals 180, stuff equals the other stuff. Classic example of 3 things being compared through transitive property. And then a subtraction step. We got one more proof on the back of your paper. Take your paper. Yep, one more. I like to do this one first by giving you an algebra problem. And at the end of this, you're going to discover a theorem that you probably didn't already know about. Maybe you did know about it. But I want you to just go ahead and dive right in and solve for x. The interior angle up here is x squared plus 15. Quadratic, we love it. The exterior angle here, it's called an exterior angle, is 5x squared. And then this one down here is 85 degrees. See if you can find all the missing angle measures. Go for it. I'll be back in the next part.